No. I presume people are aware of the cybersecurity incident that occurred in the university there on Thursday, Fridays. So we're still planning around, trying to plan around that. And I'm sure well, it's Amanda in your case, your program leader will be in touch with you later on. Well, hardly today, maybe we're kind of trying to do planning behind the scenes today. She'll probably be in touch with you tomorrow to fill you in on how we move forward, as they say, from here. Fortunately, it doesn't impact on me that much. So I'm just going to give today's lecture as planned before the incident. And we'll see how things go for the other modules for you when Amanda gets in touch with you. Just in case there are any questions from ye in relation to it, not that I will be able to answer them, but any immediate questions that I can pass on to Amanda? No? Okay. So let's do this. So eventually we're going to move on from Docker, although it's going to be part of the next topic as well, as it turns out. That's not a coincidence, though. So the next main topic that I want to look at is called CI/CD. And if we go into it, I'm not going to have a formal lab this week, although there is a short lab that I might walk through with you tomorrow, depending on how far we get today, really. But you've got the assignment to work on anyway. So I'm just going to introduce the topic really via these slides here. The context now for this is you are part of a software development team that's developing an application. And so everybody in that team is tasked with designing and implementing some part of the overall application. And you're busily working on your particular part that you're working on at any particular point in time. But of course, we need to bring together all of the different parts to make sure that the overall application is functioning at various stages during the development life cycle. Clearly, we don't do that only at the end. We need to do it much more frequently. So the question is, well, when do we bring together each team member's code, bring it together into the overall application, as I said, irrespective of what state that application is in? Do we do it at the end of each week? Do we do it every 2 weeks, or how do we go about it? And the answer is, today anyway, the answer is you do it continuously, almost multiple times a day, certainly multiple times a week. It's a continuous integration of each team member's code into the overall application structure. So CI/CD is about coordinating, if you like, coordinating the integration of each team member's uh, development work into the overall project, and also the deployment of the application so that we can see that it's functioning in whatever environment we want it to function in, whether that be a cloud-based environment or presumably it's running on some sort of server-side machine anyway. The logo there at the top, you might recognize that logo in outline form. And in fact, it's the exact same logo that we use when we talk about DevOps. So, CI/CD and DevOps are both trying to get across the same message, this idea of continuously uh, in increments, uh, building creating our application over time. It's not all design first, then all development, then all testing. We do it in increments. We code a little bit, test that code, deploy it, see it working in its deployed environment, learn from that experience, maybe actually make it available to the end user or our customers, get some feedback from them, and then use that feedback to inform the next iteration of our development process. So where kind of DevOps uh, fits in, if we wanted to kind of pin it down to some part of this, uh, it's kind of around here we're talking about, right? That's where CI/CD kind of impacts its testing as well. Although we haven't, I won't be talking about automated testing in this section. The last section I look at will be the automated testing side of things. So, that's the kind of context for this part of the module. So there's two parts to CI/CD. There's the CI part and there's the CD part. Obviously, they're linked, but we can talk about them separately initially anyway. Although in practice, we talk about them as a single practice, if you like. CI/CD is a practice. And in that sense, if we try to define what continuous integration is, and it's really what I was sort of alluding to there at the beginning of the lecture. Um, so this is telling us that continuous integration, it's a software development practice where members of a team integrate their work frequently. Now, that could be daily, certainly is multiple times a week. They integrate their work frequently, and each integration, we're told here, each integration is verified by an automated build. Now, that could be a Docker build if it happens to be a Dockerized application. It doesn't have to be, though, but it makes sense based on what we've been looking at, or we can make sense of what we mean by an automated build based on what we've been looking at earlier on in this module. Um, but we're bringing together each team member's code into one kind of repository, if you like, and running an automated build of that repository, maybe producing, as I said, Docker images. We're also running automated tests as part of that build process. So build is not just creating the artifacts like our Docker images, it's also running automated tests of the actual code. And as I said, we look at automated testing at the back end of this module. And the whole reason we do this integration and building and testing continuously throughout the development process, the reason we do it is to detect integration errors as quickly as possible. So there's no point in one person in the team writing code that doesn't actually work with other parts of the application. We want to detect those integration flaws and remove them as quickly as possible. This definition, as it turns out, is a definition provided by somebody called Martin Fowler. Martin Fowler would be a well-known a kind of guru in the whole software engineering space. The definition below, this is just an alternative definition, and it's kind of saying the same thing, but it's focused on applying quality control. And really, that's what we're getting at up here as well. We're trying to detect integration errors as quickly as possible. So we're trying to improve the quality control of our whole development process, if you like. Is there anything else interesting in the second definition? Yeah, well, the reasoning is the same. Like we want to try and reduce the time taken to, it's all about speeding up the delivery of our application to our end user, our customers. So that's fine. That's a definition. Then I suppose the next question is how and why. We've kind of answered the why, but how do we uh, achieve a continuous integration practice within a software development environment? And there are a couple of very simple practices or rules that you need to follow. Number one, you need to maintain what's called a single source repository. Now, that simply could mean have a single GitHub repository that each team member pushes their work to on a continuous basis. That's easy enough to set up, although we've never set up a GitHub repo that many people can push to, but it's not a difficult thing to do. So that's number one, have a what's often referred to as a have a single source of truth. There is one place where the most up-to-date version or the most up-to-date state of our application can be found, and that is in a particular, let's just say it is a GitHub repository. It doesn't have to be GitHub though. There are alternatives to GitHub, but it's a central repository. Number two, automate the building of your application. That's easy for us now to understand if it's a Dockerized application, but even if it wasn't, it's uh, it's possible now to automate the building of other types of applications as well. We don't want it to be a manual task. We're trying to eliminate as much manual input to this whole DevOps environment as possible, or the whole Agile environment as possible. Number three, everyone commits. It's not literally they have to commit every day, but it's, the sense is that once you have a piece of code, be it a function or a class, that you're happy it works properly, you've tested it locally, you're happy to commit that to the central repository, then you can push it to the central repository so that other team members can get access to it if they need it. So everybody is committing to the central repository on a very regular basis. The actual building, okay, each team member may build the application on their local machine for the purpose of doing local testing, but there should also be a build performed on some sort of CI server, okay, a separate server that everybody has access to. But the whole purpose of this CI machine is just to carry out the automation of the build itself. And it's a build of the current state of our central repository. And that's what we will be looking at in this part of this module. We'll be using a cloud service called GitLab, which essentially provides servers that we can use to automate our building and automate our running of tests. Number five, keep the build fast. That's okay. And there are techniques for doing that. If it's a node-based application, you don't want the build to be installing the various node modules every single time it does the build, because the build now on this CI machine, the build is going to be happening multiple times a day. Essentially, what we will be trying to achieve is that every time somebody pushes some of their work to the central repository, that's going to trigger a build of the application, a build of the entire application in its current state. because the whole one of the objectives of CI is to get quick get a quick response to, is our application functioning at this particular point in time? Is it still building properly? Are there any build errors? Are there any test errors? We want that feedback as quickly as possible. So every time somebody commits work to the central repository, that is going to trigger a build of the current state of the application. Hence, we'd like to, the build has to be uh, fine-tuned as much as possible. Number six, test the application. Okay, so we've automated the building of the application. Uh, we also want to automate the testing of the application, but the testing ideally should be done where the application is deployed on a machine that is configured as closely as possible to the production environment that is going to be running in. Um, so we'd like to have a clone of the production environment. Now, the nice thing about Docker, I keep going back to Docker, but the nice thing about Docker is that it's, this isolated principle associated with Docker, that if your application happens to be a Dockerized application, then it really doesn't matter, to a degree anyway, about the environment that it's running in, because the environment is contained within the container. But more generally, you want to run tests against your application in a clone of the production environment. Number seven, make it easy for, everybody in the team needs to have at least read access to our CI machine and to our clone of our production environment. Everybody won't have necessarily write access to both of these, but they certainly need to have read access so that they can see what's happening in our centralized automated build and our centralized automated testing. Number eight, make the process transparent. Well, that's kind of the same thing. If it's transparent, if all the team members uh, have access to the results anyway, they need to have access to the results of the automated build and the results of the automated tests. So that's the how, and the why we've kind of already covered, but to quickly go through them. To detect development problems early, to find and remove bugs as early as possible, reduce the risk of cost, because the later bugs are detected in the whole development process, the more expensive they are to remove. Increase project visibility. That's what I was talking about there in the previous slide. Deliver features quickly to our end customers. That's really the overall goal of both DevOps and CI/CD. Deliver features to our end customers so that we can get feedback from them as to whether they like the features or not, how they can be improved. Number six, improve team cohesion. That's okay. And number seven, have greater availability. Have greater availability of a deployable software. You know, your customer, if your customer contacts you and says, "Can I get a look at the current state of the application that you are developing for me?" What you don't want in response to that is to say that, we don't have anything that we can show you right now, but, come back in 2 or 3 weeks' time and we'll try and have something. You'd like to have something that can be deployed straight away, not to the production environment, but to a clone of the production environment, and give your customer or end user access to that environment so that they can essentially play with the application and give you some feedback. But to have uh, a deployable form of your application at all time is ideal. Uh, this slide is saying really the same things. It's kind of a nice acronym: better, faster, cheaper software. Cheaper in the sense of cheaper to develop the software. That's what CI stroke CD is all about. So I'll just skip over this slide. You can read it through it yourselves. So that's continuous integration, just in very high level terms anyway. Continuous, the CD part of CI/CD, what's that all about? Now it turns out that there are really two parts to CD. They're linked obviously, but there's something called continuous delivery and continuous deployment. Um, that they're very closely related, but there is a slight difference between them. If we talk about continuous delivery first, so we're told here that continuous delivery is a development discipline where you build software in such a way that it can be released to production at any time. Okay, so it's really a decision that's made by the team, the project manager, as to whether the current build, the most recent build of the application, whether that should be released to production or not. That's a decision that they have control over. It's not automatic. So, when I was talking about CI, we always have one of the objectives of CI is to always have a deployable form of your application in its most up-to-date state. Now, whether that deployable form is actually released into production or not, that's a decision that the project manager can make at any particular point in time, but it's available to them anyway. Okay. So that's what continuous delivery is about. It's about making the most up-to-date form of your application ready for deployment to production if the person or persons that make that decision should wish to do so. Continuous deployment, on the other hand, is where it's actually automatic. So at the end of each CI cycle, the application is deployed into production automatically. Now, clearly, it's only software projects and software companies that have a very, very fine-tuned and mature CI/CD process, stroke DevOps process that would practice continuous deployment, because the notion with continuous deployment is that there is no manual step in the process at all. It's all automatic. So once team member A pushes their code to the central repository, that triggers the CI process. So our application is built, the entire application is built. It's heavily tested automatically. It's deployed to a clone of the production environment. There are automated tests ran against the application in that environment. And if it passes all of those steps, then automatically the version of the application is pushed out into the production environment. So, but some software houses follow that level of automation. So continuous deployment means that every software change goes through the pipeline, being the CI's pipeline, and automatically gets deployed. Now, I guess I should really say that if I go back to the CI part of this, there is a certain, and I talked about as part of the CI process, there is a build automatically executed against the central repository. But before that build can actually happen, there will be what's called quality code reviews carried out between the team member that contributed the code and let's say a subset of the team itself, let's say the project manager. So there is kind of a review of all new code as it's being added to the central repository that is being reviewed, uh, and that's a manual step. Okay. Anyway, so that's the CD part of CI/CD, and there's two aspects to it. Again, the how and why, some of the same answers though. How do we achieve CD, whether it be continuous delivery or continuous deployment? Teams must continuously integrate. We've had all of that. Number two, run automated tests. We've had that already. So as I said, CD and CI, they're really all part of one kind of process, overall process. Number three, automatically deploy the application to a production-like environment. And this is the term that we use for that. I was calling it a clone earlier on. Kind of the formal name for it is a staging environment. So it's some server that's running our application, but that server is not available to your end users. It's only available to the team members themselves and maybe a small subset of your end users, but it's not the live version of your application. So that's a staging environment. And the why is all of the stuff that we've kind of already talked about. This is kind of a visual that I picked up, which shows us what CI/CD looks like in kind of a visual way. Now, how software houses actually realize this whole CI/CD objective may differ slightly. So it's not that every CI/CD process are exactly as they're illustrated here, but you get the general picture from it anyway. So the first part of the this is Maria showing us the different stages or different steps in a CI process. This is showing us the different steps in a continuous delivery process, and the one at the bottom is showing us the different steps in a continuous deployment process. And just to quickly go back over it, so we have our central repository, let's supposing here, and somebody commits to that central repository. That triggers the build of our application's current state on some CI machine. The next step, if that build is successful, then there are some automated tests run against that build. If they're all successful, the current state of the application is deployed to a staging environment. And if that deployment is successful, then there are some more tests run, automated tests run against the application in its staging environment. And if all of that is successful, then it's a successful integration based on which was triggered by some team member contributing some code to the central repository. Continuous delivery then has the exact same initial stages, but the last step here, where we deploy it to the production environment, going from this step to this step is a manual step. So somebody has to press the button to say you can actually deploy the current version or state of our application from the staging environment, deploy it into the production environment. And that's the actual deployment will happen in an automated way, but somebody has to trigger that step. Whereas that's continuous delivery. In continuous deployment, that step is automatic. Okay. So it's kind of the high level view of this whole CI/CD uh, aspect of software engineering. Now, just give me 1 second, please. So how do we achieve it? Oh, sorry. Got two more slides before I can talk about how we achieve it. This slide is titled CI metrics. So if you are a software organization and you do practice CI, then how do you know whether your CI process is a good one or not, whether it's successful or not? And so the way we assess whether anything is successful or not is by measuring it and monitoring those measurements or metrics. So the answer to this question is you need to measure your CI process or maintain some metrics on the process. And the metrics, some of them could be, these are options that you might pick as your metric. I mean, the simplest one is, does the actual build, how frequently is our build a successful one? The build being just the very first stage in the process, yeah? Like if this is always failing, then clearly, we need to identify, well, why is it failing so frequently? And that's probably because however you automated it needs to be fine-tuned. So that's a very simple metric. Another metric is, okay, your build stage may fail, not so much regularly, but it does fail every now and again. How quickly, and that's maybe just accepted as part of the world that we live in, depending on the nature of the application. The next thing is, well, how quickly can we actually repair the builds? And if the turnaround time is very slow, then that might be an indication that your CI process is not a good one or it's not a successful one. Or alternatively, if part of the build may actually include carrying out some static analysis of your code using what are called static analysis tools. And these static analysis tools, and you may have come across some of them already, in the JavaScript world, we talk about linting tools. And what these static analysis tools do is they just look through your code, trying to identify poor quality code. The code may work, okay, but it doesn't follow good coding practice. So if we do have static analysis tools as part of the build process, then are these tools always identifying defects in our code? And if they are, then that would cause the build to fail. So, and that really goes back to your software developers maybe not following best practice in their coding style. Another option is unit tests, line coverage. In general, when we're writing automated tests for our code, even though the tests may all pass, if they're not well thought out tests, then there may well be parts of the application that our tests, our automated tests, never actually exercise. What you want to try and ensure is that your automated tests do exercise all parts of your application. And that's what's referred to as line coverage. That each line of code, the notion is that each line of code in the application has been exercised at least once by your automated tests. Now, if there are large chunks of code that are not exercised by your automated tests, then clearly those test cases that have been written are poor. So you're trying to aim for high line coverage. Okay, so they're all kind of metrics. Uh, some of them, some of the metrics anyway, that you might use to assess the quality of your CI process. And there's no point in having these metrics if you don't pay attention to them. So this would be just in kind of real life now. So monitor the metrics that you've chosen as the ones that you're going to use to assess your CI/CD process and act on them, I think is kind of the mantra. What else are we saying here? They should provide immediate feedback. That's okay. They should be easily accessible. That's okay. They should require no development effort. That's okay. CI metrics, I think that's okay as well. Right. This is the slide I thought I was moving on to. So, how do we actually uh, kind of achieve CI/CD? How do we automate all of this CI/CD practice? And it is about automating it. And there are lots of platforms and tools and technologies out there that we could use. And I've just chosen one called GitLab. It's not necessarily the best one. It's not certainly not the worst either. As I said, there are lots of them there. But the nice thing about GitLab is that it's essentially it's free, and it is very popular in industry. Although, as I've already said, there are alternatives for sure. And really, the alternatives do the same as GitLab. So they all do the same there, thereabouts. They just have they might have extra little benefits over others. But we're going to look at the GitLab offering anyway. So you will need to, and I would have mentioned this on day one, you need to go to the GitLab website and create an account for yourself. You will need to provide a credit card as part of the sign up process, but as before, we will aim to minimize, in fact, hopefully not actually incur any costs at all. So if you haven't done so already, you do need to create an account on this service. As to what GitLab is, as as the name kind of suggests, it is actually a hosting service. So it it's just an alternative to GitHub. GitHub is a hosting service as well, hosting your source code. But it has lots of other parts to it as well, not just the code hosting side to it. It's open source, that's fine. It's free, although you can run the GitLab service on your own private servers, and some organizations do that if they are fearful of hosting their applications out on a cloud service. And it's actively maintained. And so the visual down here shows you the different uh, components that make up this GitLab service. So at the very center of it, it's just a Git repository, you know, which is exactly what GitHub is. But then there are all these other parts. Down here, we have a part that supports CI, and that's one that we're very interested in. Coincidentally, over here, it does actually have its own uh, Docker repository, a container repository. Okay, so that's an alternative um, to Docker Hub. We won't. I don't think we will use it. We may, but it's just an alternative to Docker Hub. And then some of the other parts. So, for example, this part here, user management. So a you can create a repository and then manage the different team members' access to that repository and to the CI part of it. So we won't need to get involved in that at all. Uh, Issue tracking for bugs that are detected during the CI CD execution. We need to somehow record those bugs somewhere and assign people to fix those bugs. So that can all be managed using the uh, issue tracking uh, component within the platform. And there's also a kind of whole project management side to it, taken care of here. I'm not sure what this part is about, actually. I meant to look it up. So GitLab is really, it's kind of a one-stop shop for all aspects of application development, not just the code hosting and the CI/CD part of it, but the project management, issue tracking, the whole lot, really. Although, as I said, we're only going to be using the Git repository and the CI parts of and maybe the container registry. Like, I've forgotten actually whether I've included that in the labs or not, but it's not a big deal anyway. Uh, So focusing in on the Git, sorry, focusing in on the GitLab CI component within the GitLab service. Uh, First of all, it's fully integrated with the GitLab repository. And so whenever we push a change to a particular repository, uh, GitLab repository, that will trigger a CI execution for us. And we'll see that in the labs, a CI/CD execution. We refer to the CI/CD, the automated CI/CD process, as being a script. So we write a CI/CD script for a particular repository. Although it's not a script in the conventional sense, it'll actually be a YAML file. Git hooks, that's all right. Let's skip over that. Uh, it's built as coincidentally, it's actually built on top of the whole containerized model, and that will become very evident when we start looking at the detail of these CI/CD scripts, and I will focus in the uh, on that fact when I start explaining these scripts, and they'll make a lot of sense to us given how much we know now about containerization and Docker in particular. Although you don't have to use the containerized part of GitLab CI, it is actually optional, but we certainly will be using it. So that's fine. That's kind of in general what GitLab CI is all about. And why should we go over this code and build? It turns out now that in our repository, in our Git repository, clearly we're going to have the source code for our application, but we're also now going to have the CI/CD scripts, which we actually generically refer to as build scripts, even though the use of the word build here might suggest it's only one part of the CI/CD process. But I'm using the word build script here now to refer to the entire CI/CD description, if you like, or declaration. But it is code, okay? And so we can do version control of our CI/CD scripts just as we use version control on our source code. And that's kind of nice because we can roll back to earlier versions of our build script if we need to. You know, we might add some code to our build script, which doesn't work when we try and trigger a CI execution. And so we want to undo the changes that we made. Well, it's going to be very easy for us to do that in the same way that we would do it with source code. It's easy to get, okay, that's all right. It's scalable, it certainly is, although we won't necessarily worry too much about scalability. Isolated testing environments, that's okay as well. So to get into the kind of mechanics of GitLab CI, so let's go back now to here. And clearly, I don't need to talk about this because we're all very familiar with GitHub, and the GitLab repository is really the exact same. So our focus is completely here. So how do we actually write a CI/CD script to automate the CI/CD process for the source code in a particular GitLab repository? And so there are three kind of constructs that we need to be familiar with, and they're pretty straightforward. And the constructs are called pipelines, stages, and jobs. And we're told here that we declare a CI/CD process using these three constructs. And how they're related is a pipeline is comprised of multiple stages. A stage is comprised of potentially multiple jobs. Okay, so a job is the smallest unit, if you like. A job is part of a stage, and a stage is part of a pipeline. So a pipeline is a group of jobs that get executed in stages, okay, or batches. So a pipeline is a group of jobs, a collection of jobs, and those jobs get executed in stage batches, if you like. So all of the jobs, we're told, all of the jobs in a stage are executed in parallel. So you've got to make sure that, although we won't worry too much about that because in most of our cases, a stage will only have one job in it, but potentially can have multiple jobs. But you need to be aware of the fact that those jobs are executed in parallel. So you can't really have dependency relationships between the jobs in a stage. If one stage job, if a job fails, then the entire pipeline is deemed to have failed. So when we trigger our CI/CD, so we can now talk about our CI/CD pipeline. When we trigger the execution of our CI/CD pipeline, if any job in that pipeline fails, then the entire pipeline is deemed to have failure and it won't execute any of the jobs after the failed one in the pipeline, clearly. How do we actually physically code up this pipeline comprised of stages and jobs? We put it into a file of type YAML, and the file has to be called this exactly. You've got to give it the exact name of .gitlab-ci.yaml. And that file must be located in the base folder of your project. So really our focus is going to be almost exclusively on this file and what we can put into it. If you know anything about YAML, this is a really important thing to know about YAML. YAML is used for lots of different use cases. Here we're just using it for describing a CI/CD pipeline in the GitLab environment or the GitLab platform. But the thing about the YAML syntax is you've got to be very careful about indentation and alignment. If you are careless about indentation and alignment, then you won't get the results that you would have expected. So just bear that in mind. So here's a very simple little demo, right? So up in the top left, I have showing you the contents of my project in VS Code. Now there's actually no source code in this because it's only a demo, but I have a SRC folder, Maria, but there's nothing in it. Here's my Git ignore, that's fine. And here's my GitLab YAML file, as we call it. And here's the contents of the actual YAML file. And if I just switch over to VS Code and I will uh, get a better look at here's the project. And I've already created a repository up in GitLab. Let's have a look at that. Here's my GitLab account. And if I go to projects, I've got a couple of them. The one I'm interested in is, okay, at last, right? So this is my GitLab repository. Nothing special about that. And that coincides with what I'm showing you in VS Code. And if we look inside the YAML file, so going from the top down, it looks like that these are the different stages in my pipeline. So my pipeline has 3 stages, and I've purposefully given them generic names, but normally the stages would be something like build, test, deploy, that kind of idea. But I've just called them stage 1, 2, and 3. So that defines the stages in my pipeline. And from there down, then I'm describing the jobs in each stage. So if we take this job here, and I want to take out that line there for now. Let's just comment that out and pretend it isn't there. So I've got a job called job A, and you can call the jobs anything you want to. Also, you can call the stages anything you want to. So I've got a job called job A, and it looks like it's part of stage 1. And this part here then is the what I want executed by that job. It's it's just the execution. Now I'm just executing simple echo commands, so it's not doing any building or testing or anything like that. Okay, so the script part of a job is where you declare or define the different steps that the different commands, I suppose, that the job needs to execute. Okay, so I'm just doing some echoing, and I'm echoing, as it turns out here, there are what are called uh, GitLab variables available to you as well. These variables are automatically defined by the GitLab environment for you. So, for example, the variable called CI underscore pipeline underscore ID is, as you might expect, an ID that has been just generated for a particular pipeline execution. And I'm just outputting it there as part of that echo command. Um, Here's another job, and it looks like this job is part of stage 2 in my pipeline. And again, my script is just echoing and doing anything else of interest. Job C is also part of stage 2. So when I trigger the execution of this pipeline, job B and C are going to be executed in parallel. And job D is part of stage 3. Yeah, so that's an example of a pipeline, and just the syntax and the structure of the YAML file is all we're interested in at this stage. Now it turns out like that each of these jobs is actually executed inside a container, and specifically whatever you have specified as the script for the job, that is executed inside a container. And we know what that means now, given that we've done a lot of stuff on Docker containers, and it will be Docker containers in the case of GitLab. Okay, I'm tempted to keep going, but I won't, even though you probably don't have any classes after that. So for tomorrow, I will touch base with you in the morning. What I might do is just give a short demonstration of um, triggering the execution of this pipeline and showing you how you can see. I mean, the obvious question is, where are these echo commands? Where can I see evidence that they have actually executed? And the GitLab environment will enable us to do that. So for now, I'm going to stop it at this stage and I'll touch base with you in the morning. I'll have a maybe a 30-minute, 40-minute lecture in the morning, and then I will let you, I'll actually give you this little demo project and let you create a repository on GitLab, push this project up to the repository and trigger the execution of this pipeline and just play around with it really. Now, just what I want to do this morning is get you started using the GitLab CI service. So I'm just going to give you a quick demo and then in your own time, you can just essentially repeat what I've done. And next week, then we'll have a full lab using GitLab CI. And what we'll do is we'll take the user profile app as our kind of context, and we'll develop a more reasonable CI/CD, well, CI initially, pipeline for that. And then the following week, we will do a full CI/CD pipeline where we will deploy a simple, probably a web app onto an EC2 instance, an Amazon EC2 instance. So if you haven't already done so, you'll need to create an account on the AWS platform as well. But that's a couple of weeks away. So I gave you an introduction to this whole CI/CD practice yesterday, and it's really all about um, supporting a software development team, trying to ensure cohesiveness of that team in the sense that each member will be developing some aspect of an application, and we want to, at very regular intervals, integrate the work of each team member into our application, test it, deploy it to what we call a staging environment, which is something very similar to the production environment, test it um, in that environment, and then potentially either automatically deploy it to the production environment or have that deployment to the production environment something that's controlled manually by, let's say, the project manager or team manager. There's lots of platforms out there that we can use to implement this CI/CD practice, and the one that we've decided to use is GitLab. So GitLab has many aspects to it. The parts that we're really interested in is the fact that it has a repository side to it, which is the exact same as GitHub, and it has support for CI/CD. They're the two parts that we're interested in. And these two are linked together. And by that we mean when you push an update to a particular Git repository, if that repository has a CI/CD pipeline defined for it, then the CI service will automatically execute that pipeline. And I'll show you that working this morning. So what you need to do after I finish this lecture is you need to go to the gitlab.com website, really. Create an account there for yourself. So I've created my account and I've logged into my GitLab account. You should then create a new project. A project is essentially a repository. So if you just click the plus here and select new project, choose the clear, create a blank project. Then give it any name that you choose. So I'll just call mine demo. And you should make it a public repository. Untick everything that's automatically ticked and then create that repository, stroke project. So I've got a blank Git repository at this stage. Just grab the URL of that repo and Git clone it. So if I copy that, go back to VS Code or an ordinary terminal prompt and run git clone for that project. So I'm not going to do that now, but there you would go git clone, the actual repo, hit return, then import that local copy of the repository into VS Code, and it's going to be blank initially. Then what you will do is copy the contents of a project that I will provide to you. So I will upload the project to Slack after I've finished this lecture and import all of the contents of the project that I'm giving you into your empty local repository. And so what it will look like is what you see here on the left. And all we are really important or interested in is this file here. This is the file that declares the pipeline for this project. Now, there isn't really anything in this project as such. So, and I talked my way through this file yesterday. Yeah. So let's supposing we've done that now. We've copied in all of this into the project. So we can now do a git push to the GitLab repo. And in the README, I'm showing you that the first time you do the git push, this is the command that you should use. Effectively, what this command is doing is it's setting the origin remote repository to the repository that you have created up in GitLab. Okay. Now, GitLab doesn't use master as the name for its central branch. It uses main instead. So I'm linking the main branch of my local repository here I'm linking it with the GitLab repository that I've created in the cloud. And I'm calling that remote repository origin here locally. So whenever I do a git push origin main, for example, down here, whenever you do a git push origin main, you are pushing any updates that you've made to the local project. You're pushing it up to the main branch in the remote origin repository. And the remote origin repository is the one that we have just created. And we're creating that connection here. So when you copy all of these files into your local project, and then you do this, that's going to push all of this stuff up to the repository that you have created up in GitLab. But what GitLab does is it will notice that there is a file called .gitlab ci.yaml, and the presence of that file is going to trigger the execution of the pipeline that you have defined inside in this file. So in other words, this here now kicks in. The GitLab CI/CD service, if you like, starts to take over the execution of your CI/CD pipeline. Now, how can you see the results of that pipeline execution? Well, if I go back to GitLab, so I'll actually go to another project that I've created, which contains this exact uh, content. So if I go back to here and select personal projects. So for me, this project here, excuse me, this project of this repository, if I go into it, so you can see the contents is exactly as I showed you here in VS Code. Although we're missing the SRC folder, and that's really because there's nothing in the SRC folder at the moment. But if you did, you could put a temporary file in there. It's going to be ignored anyway. Um, and the reason the README doesn't appear is because I just copied it in at the moment. I haven't pushed. Actually, I could do a push. Maybe I'll do it in a moment. But here's the YAML file. Now, if you open the sidebar menu and if you go down to the build option, and you can see from there, it's allowing me now to look at the various pipeline executions that have been executed for this project. I could look at individual jobs. If I go to the pipelines option, it's now showing me the various executions of my pipeline that I defined in the GitLab ci.yaml file. And you can see I ran the pipeline a number of times. So we can see here that there are 3 stages in my pipeline. And that's consistent with, if I actually look at the pipeline, here are the 3 stages. There are 4 jobs, job A, B, C, and D, and I talked about this yesterday. Job A is part of stage 1. Job B and C are part of stage 2, and job D is part of stage 4. And if I go back to the pipeline execution, so this is stage 1, and if I just left click on it, it's listing all of the jobs that were associated with stage 1, and the tick means that the job seems to have executed successfully. If I click on stage 2, it's telling me there were 2 jobs, B and C. And if I select any one of them, if I select job B, for example, it then shows me the result of the execution of that job. And what we're seeing here is the console log that was generated during the execution of that job. Now, if you look a little bit closely here, you'll see it's actually talking about a Docker image. So each job is executed inside a Docker container. Now, if we go back to my pipeline, I'm not mentioning anything here in the pipeline. I'm not mentioning anything about Docker images, but you can specify a Docker image. And well, in fact, I am mentioning it there, but I commented that out for the execution that I just showed you. If you don't specify any Docker image, then it selects a default image for the execution of your job. But you can be specific about it. And you recognize BusyBox as being an image that we used when we were talking about Docker. But it seems that if I go back here, that the GitLab chose a default image, which is this image here. It's an image that contains an installation of the Ruby programming language. Um, and okay, so that's the image that it used for the container instance that it created in order to execute this particular job. Now, by execute the job, what we mean is it executes the script that you have declared for that job. Okay, so I think we were looking at job B. So job B has, there's an inconsistency now between what you're seeing. Well, maybe not. There's an echo command, and the echo says to echo this is, and I'm just using a variable that has been defined by GitLab for me. So job name, CI underscore job underscore name, that will be initialized to job B in this case. And I'm also using a variable called CI job stage, and that will be initialized to, in this case, stage 2. So this echo command should output this is job B in stage 2. And is that what it gets? That looks like what I'm getting here. Uh, okay, the exit, I've commented out the exit command. We can talk about that next week. So what I would like you to do is create a project stroke repository in GitLab, clone it, then copy in the project that I will provide to you into your local copy of that repository that you've cloned, and then execute this git push command, then go back to GitLab and check that the pipeline has executed successfully. And then you could maybe make a small change. Look, you could just change the README file. It's not going to affect anything. Make a change to the README file, then execute this git push command, and it will execute your pipeline from beginning to end again. So you should have two executions of your pipeline available, visible to you up in GitLab. And again, to see the pipeline, just select the build option here, build and pipelines, and you will see the outcome of the execution of the pipeline. And if you want to drill down to a particular job, just click on the stage and select the job that you're interested in. Let's say we're interested in job A, and then you'll see and correlate what you're seeing here with the actual job declaration in the YAML file. So job A had two echo commands, it looks like. And are we getting two echo commands? It looks like we've got one echo command and two echo commands. Okay, that's about it really. So I will let you work away and I will post a message on Slack that contains the the contents of that kind of skeleton project that I've just been looking at. Are there any questions? No. So I did say it was going to be a short lecture, and that's the end of the lecture. So I'll let you work away, but I will monitor Slack for the remainder of this lab if you've got any problems following what I've asked you to do, or if you've got any questions on the assignment, which is, as you know, is due today. Okay, I'll leave it at that and get in touch with me on Slack if you've got any questions for me. Thanks. Bye bye.